Okay, this is our third reaction type. It is called single replacement, right? So single means one. We know that. I knew that for 10 years after college until I met my wife, which is kind of awesome. But single means one, and to place something means to put it somewhere, and means to do that again. And so that means we're going to put a single element somewhere new, okay? So an example of this would be if I have a compound, okay, and then I have a side element, a single element, and what's going to happen is this element, depending on what type of element it is going to replace one of these two elements. So let's assume that our metals are positive, nonmetals are negative, and let's assume we have an extra negatively charged ion. Well, in this case, then A would stay there because you cannot have negatives and negatives together. C would take the place of B. It would replace B, and B would be single again. Right? So whenever you have a compound here and a single element, you have a single replacement reaction. So, and here's an example. If I have aluminum chloride, okay, and then I'm going to add calcium. Let's use our periodic table here. So, periodic table, I'm finding aluminum, bam, it has a +3 charge. Chlorine, -1, and calcium over here, +2. So I can write those charges down because I'm going to use them. They're the key to understanding this stuff. Okay? So now, those charges will never change. But I know that positives replace positives and negatives replace negatives. So since I have two positives, I'm going to replace this aluminum with calcium and put aluminum out here by itself. Single replacement. Okay? So I'm going to have calcium chloride and aluminum. Okay? And now I need to just rewrite my charges. The charges never change, right? The number of elements might, but it depends on the charge. So when I look here, I have a +2 charge and a -1 charge. And that becomes a problem for us because we have to have equal charges to make a compound. In this situation, we just need to have 2 chlorines so we can have a total negative charge of -2 to match our +2. And if you can think about it that way, or you can just recognize that if these are unequal, you can just crisscross and drop that number. That tells you, the difference between them tells you the number of each element you need. So another example would be if I had a compound, let's say it was aluminum oxide. Aluminum is +3 and oxygen is -2. Instead of figuring out how many of each one I have, if I simply crisscross, I put the 2 with aluminum and the 3 with oxygen, I'm going to end up with a balanced compound. So you can just crisscross these and it gives you your answer, right? Because +3 times 2, +6, -2 times 3, -6, and it's balanced. Okay? And remember, this is single replacement. We have a single element and a compound that gives away that type of reaction.